Greetings Fire Chargers, Darkblade here, and in this video we are going to talk about why mass does not affect falling speed. First things first, let's everyone make sure to pray for Charles III, King of the United Kingdom, and all his other domains. I heard the news that he recently got diagnosed with cancer, but he is receiving regular treatment and has an overall optimistic look. So let's see. What do we know? We know that the force of gravity exerted by two objects onto each other is equal to the universal gravitational constant times the mass of the mass of the first object times the mass of the second object divided by the square of the distance between them. We also know that force equals mass times acceleration. So if we want acceleration on its own, we have to divide by the coefficient. So that means acceleration equals force divided by mass. So this is force. So that means that the acceleration due to gravity is equal to the force of gravity divided by the mass, which is equal to... By the way, I have to one-hand my tablet as my other hand is being used to do math. The universal gravitational constant times the mass of the first object times the mass of the second object divided by the square of the distance, which is then, and that is then divided by the mass of the second object. So this means that we have one of the terms in the numerator is the mass of the second object, and one of the terms that ends up in the denominator is the mass of the second object. So that means we end up dividing the mass of the second object by itself, so it cancels out, and we're left with just the universal gravitational constant times the mass of the first object, which in this case is Earth, divided by the square of the distance that the object is from the center of the Earth. So that means that no matter what the mass is, it doesn't matter for the purpose of the falling speed, as the object's mass ends up dividing by itself, which just cancels itself out. This also means that the common figure 9.8 meters per second second squared is not all that accurate. Now, on this, wherever you are on the surface of the Earth, yeah, that acceleration due to gravity is going to be really close to 9.8 meters per second squared. However, when you're not on the surface, all bets are off. For example, if you're on the surface, then you're about 3,960, a little less than that, miles away from the center of the Earth. However, let's say if we wanted to triple that, so now you are 11,880 miles away from the center of the Earth. The acceleration due to gravity would then be only about 1.09 meters per second squared. And 11,880, you would be 11,880 miles away from the center of the Earth. However, you would actually be about 7,920 miles from the surface of the Earth, which is about roughly equal to the diameter of the Earth. So you're about far enough away from Earth that you could fit another Earth between you and the Earth. And when you're that far away from the Earth's acceleration due to gravity on you would only be 1.09 meters per second squared, regardless of your mass. Because remember, the mass of the second object is divided by itself, so it cancels itself out. So it's really just the universal gravitational constant, the mass of Earth, those two multiplied together, divided by the square of the object's distance from the Earth. Goodbye, Fire Chargers, Dark Blade here, and make sure to like and subscribe.